the is relatively easy for us. So I numbered the examples. So this would be example 3. Yeah? Yes. Okay. Okay. If we have y equals negative cube root of x plus 5 minus 3. Now, in the video, I showed you kind of writing out all the steps of what happened to x so that we could do them backwards. That's not an efficient way to do the problem. It was just to make sense of it from the notes. Does that make sense? I just wanted you to kind of understand where it came from. So here, instead of writing down all the words, we're just going to start doing the steps. Okay? So whenever we want to solve for x, which is eventually kind of what we're going to do, we're always going to do order of operations backwards. Okay, so when we do inverses, the very first thing we do before we even try to isolate anything is what with the x and y? Switch them. Okay, so very first step is to trade x and y. So I'm going to have x equals negative cube root y plus 5 minus 3. And then afterwards, I'm trying to get the y all by itself. And anytime I isolate a variable, I have to do order of operations backwards. Okay? So that means that now I'm going to see if there's anything I can add or subtract to the other side. 3. So plus 3, x plus 3 equals negative cube root y plus 5. Okay? The next step is to see if there's anything I can multiply or divide to the other side. Anything I could multiply or divide to move it away from the y? The negative sign. So I can think of it as dividing by -1, or I could go ahead and multiply a negative to the other side. It doesn't really matter how you think of it because it would accomplish the same thing. So that means that I've got cube root of y plus 5. What happens when I divide by a -1? What do I get? Negative x minus 3. Okay. My next step is to take care of any exponents I could see, or I can introduce an exponent if it could help me get rid of something. So I should cube it. It's a cube root. If I want to get rid of the cube root, then I should cube each side. So on this one, instead of getting rid of an exponent, we're introducing an exponent, and it's helping us out. So I have negative x minus 3 cubed equals y plus 5. And then at this point, our grouping symbol was the cube root. That's the equivalent of the parentheses for this problem. We didn't have parentheses, but we had something else that grouped it. So the last step is we would say P for parentheses, but it's really to just figure out what you need to do inside the grouping symbol. So the part that was inside was the y plus 5, so now what should I do? Subtract the 5. So I've got negative x minus 3 cubed minus 5 equals y. And at this point, I double check my notation. So the original problem said y equals. So what should my answer say? Y to the -1, so y inverse equals that stuff. And now we're done. Yep. Eventually, once we do enough, we're going to do more with inverses tonight. We'll look at tables and we'll look at graphs. But eventually, when you hear inverses in your head, you're going to think trade XY. Because that's exactly what you do. And it's what you do this year. It's what you do in pre-calc. It's what you do in calc. Eventually, whenever you hear the word inverse, you're going to be like, yep, just trade them. Trade them, done. Yep. Because that really, as far as math goes, that is the only part that was new. Nothing else was new. Everything else was old. We've done it all before. Okay. What if we have f of x equals 2/5 x minus 7. All right. Now, some students are very comfortable with fractions, and so for those students, we could kind of leave the fraction in the problem. Some students are not comfortable with fractions, so for some of us, we're going to fix it and make it a little bit easier to deal with, okay? But the very first thing that we do is what? Trade x and y. So I'm going to say x equals 2/5 y minus 7. The other way you can do this exact same problem is you can say x equals 2y over 5 minus 7. So I did step 1, I traded x and y. Step 2, is there anything we can add or subtract over to the side with the x? 7. We're going to go ahead and add 7. So we have x plus 7 equals 2/5 y, if you're comfortable with that. Or we could say x plus 7 equals 2y over 5. So the third step says, what can we multiply or divide over to the other side? And this is the step where it might be helpful to have written the problem this way. So if you wrote the problem this way, what would you probably do next? Multiply the 5 over, right? Okay, so if we multiply the 5 over, then we have 5 times x plus 7 equals 2y. You can distribute the 5, so what do we have? 5x plus 35 equals 2y, okay? Now we're not done multiplying and dividing. What can we do now? Divide by 2. Okay, so you can leave it as 5x plus 35 over 2 if you want to leave it as just one big chunk. Or you can call it 5 over 2x plus 35 over 2. Both of those answers are totally fine. Now, we got to skip step 4, we got to skip step 5. We had no exponents to take care of. We didn't have any grouping symbols on this problem. But when we get down to step 6, what notation are we supposed to have? Yeah, is it with a y? It's going to have to be f inverse to match the original problem, okay? So 2 good answers for this problem. We can say f inverse of x is 5 over 2x plus 35 over 2. Or we can say f inverse of x is 5x plus 35, all divided by 2 as one chunk. Those are both good answers. Okay. Now, this side, for students who are not very uncomfortable with fractions, students who are pretty comfortable or okay with fractions, how could I get rid of a 2/5? Multiply by the reciprocal. So I would say, let me go ahead and multiply by 5/2. Because I know that multiplying by 5 and dividing by 5 cancel out. And I know that multiplying by 2 and dividing by 2 cancel out, and that leaves the y alone. So if I multiply by 5/2 on one side, then I have to multiply by 5/2 on the other side. So I get y equals 5/2 times x plus 7. Now from here, you could say, all right, I'm going to distribute the 5/2. And that's where you would get 5/2 x. The 7 is technically over a 1. And so then you would get 35 over 2. So you get the same answer, but it's a little bit less, it's quicker to deal with, but it's a little bit less comfortable because you have to remember to do the reciprocal. You have to be comfortable distributing a fraction. It's just a little bit different overall. You get the same answer though. So they're both mathematically sound. You guys okay with that? All right. How do you feel about the inverse stuff in general? Pretty good? Okay. So today I have a coloring sheet. I mean, if we're going to be here